So if the pH is the negative log of the concentration of the hydrogen, in that problem we just worked, what's the concentration of the hydrogen? 1.2 times 10 to the minus 3. So what would the pH of that solution be?
Or did you just plug it in? Negative log?
Yeah, the negative log of the 1. What do y'all get?
2.92.
2.92 for a pH. And pH has no units. It's just pH of 2.92. Okay, there's no units there. Everybody okay with that on your calculator? Okay, we said by looking at the concentration numbers earlier, when we worked that original problem here, just by comparing the concentration of the hydrogen and the hydroxide, we knew this was going to be an acidic solution, right? Because it was greater. And now we can tell from the pH, yes, indeed, it is acidic because the pH is less than 7. Now, pH, it's a base 10 logarithm scale. So let me point something out to you guys. Your exponent, like right here, 1.2 times 10 to the minus 3, this number gives you a ballpark of the pH. Okay? It's around 3. Just a second ago, we were talking about the hydrogen ion concentration of water, right? And the hydroxide ion concentration, and we said that those are equal in pure water, right? What did we say it's equal to in pure water? We said that pure water has a hydrogen ion concentration equal to the hydroxide ion concentration, and we said that would be 1 times 10 to the minus 7. Each of those would be 1 times 10 to the minus 7 molar. What is the pH of pure water? 7. How do we calculate that? Well, wouldn't it be that the pH is equal to the negative log of 1 times 10 to the minus 7? And I just said that the exponent in the concentration gives you a ballpark of the pH. If it's 1 times 10 to the minus 7, then the pH will be 7, whatever that exponent is. So the pH of pure water is 7. If the pH is the negative log of the hydrogen ion concentration, how do you think you would calculate a pOH? You might not have heard of that, but there's a pOH reading as well.
Negative log of OH.
Yes. A pOH is simply the negative log of the hydroxide ion concentration. So again, going back to that problem we worked earlier, if the hydrogen ion concentration is 1 times 10 to the minus 3, well, we use that and we calculated that hydroxide is 8.3 times 10 to the minus 12, right? What do you expect the pOH to be around?
12.
Around 12, right? So let's see what it is. Oh, y'all are faster than I am. What was it, 8.3 times 10 to the minus 12?
Yes,
And so pH is 11.08, right? I'm sorry, yes, pOH is 11.08. So you can use that exponent in your concentration as a ballpark, okay, and watch that, and you can check what you're doing. Huh?
All right, I'll leave. This is the easy stuff. Now let's see the real deal.
Okay.
It always starts out easy.
I know it does, but you got to have a foundation.
No, let's
Yes?
just
Well, what did he jump in? Let's go. Okay. Unfortunately, I've got 2 slides here, but Y'all, if the pH is 2.92, right? We're still all on the same solution, aren't we? If the pH is 2.92 and the pOH is 11.08, do you guys see that the pH plus the pOH will be equal to 14, always? Do you see that that 14 ties back to what the KW was? What's the KW? 1 times 10 to the minus 14. Okay, so a pH plus a pOH will always be 14. Okay, so that's a formula, a summary of the formulas that we're using. Guys, depending on what information you start with in a problem, that's nice. I mean, there's different paths to getting to the right answer, okay? So we're going to work a few. I want you guys to be comfortable with these formulas. I want you to know them like the back of your hand. I'm going to write them on the board on the test because I don't want you missing something that simple, because it is simple. What if I told you that the pH of a solution is 4.37? A solution has a pH of 4.37. From that, I want you to tell me what the pOH is. I want you to tell me what the concentration of the hydrogen ion is. And I want you to tell me what the concentration of the hydroxide ion concentration is. What are you going to do first?
Subtract 4.37 off 15.
Yes. We know that the sum of the pH and the pOH is 14. So by simple subtraction, we all know that the pOH is what? 9.63. Are you okay with that? Do you know what to do with those numbers to go to the hydrogen ion concentration?
With pH.
10 negative 4.36.
Yes. If the pH is 4.37, I'm going to go back a slide, then I can use this formula, and I know that 4.37 is equal to the negative log of x, right? And x is what I'm solving for. How do I solve for x, y'all? What do I... What's,
Use a little e.
10 to the x.
not the e. That's the natural log.
Would you take 4.34 and divide it by a negative log?
Well, yes, but what does that do?
Leaves you
This is...
H.
What you're actually doing is you're saying 10 raised to the negative 4.37. That's an inverse log. 10 to the x on your calculator, isn't that what the inverse log is?
Yeah.
If you look above that button on your calculator, it says 10 to the x, and it's this function right here.
Why is it 4.37? That's what the pH.
That's what the pH is.
Oh, I thought you said 4.34.
Isn't that right?
Why is it extra to 4.34?
Okay. Why is it negative? Because there's a negative right here in the equation. So when you enter that in your calculator, 10 raised to the negative 4.37, that gives you H. What do y'all get?
4.3 times 10 to the negative.
Yes, I got 4.27 times 10 to the minus 5 molar. Or 4.3, that's fine to say 4.3 times 10 to the minus 5. Is everybody getting that? Are y'all okay with that step? It doesn't have to be, but I would want it because I wouldn't want to write .0000043. It's just me.
Or like the next one where it's negative 10.
Yeah.
0, 0,
Okay. Can we move on? Some of y'all, I guess, are already moving on. Y'all, how are you going to get hydroxide? There's two ways to do it. You can say 10 raised to the negative 9.63, can you? Right? Or couldn't you say that the KW, 1 times 10 to the minus 14, divided by this? Either way, both ways give you the same answer. Okay, so you figure out however you want to do it, what the hydroxide ion concentration is, and tell me what you get.
2.3 times 10 to the negative 10.
Is it positive or negative 9.63?
Negative, because it's pOH is negative log of OH. (2.3 times 10 to the minus 10 molar.